Okay, and hello everyone. Welcome and thank you for joining today's snapshot. So I'm Kang Zhen. You can call me KZ. I'm a solutions engineer based in Singapore. So before I go deeper, I'd just like to talk about the test pyramid. And this concept in itself is not new to many, especially application developers. So the idea here is at the bottom of the pyramid, we have unit tests, followed by contract, integration, and end-to-end tests. And the idea here is as we move up the pyramid, the time and resource needed to run the test increases, which is why many organizations like to focus their effort at the bottom of the pyramid, especially through unit testing. So for unit testing, we are trying to answer the question of, does my configuration or plan contain the correct metadata? And as an example, say we have a module that performs some form of processing for an input variable. And the point of the unit testing is to ensure that the output of the module is as expected. So say we have a module that does some form of processing for a given string, say to add prefix. And when we do a Terraform plan, we want to make sure that the prefix is correctly added. And for contract testing, we look at the question of, does the expected input to the module match what I think I should pass to it? So in essence, here we are just relying on some form of validation, pre and post processing checks to make sure that the given input to a module is allowed. And some examples of checks are things like setting a range of acceptable values or having some form of post-processing checks to make sure an AMI is of a certain OS. And for integration tests, we check if the module can integrate with its upstream or downstream dependencies correctly. So maybe I'm spinning up an EC2 into the VPC, and we look at whether the EC2 is spun up into the correct VPC and subnets, and whether the proper networking configuration has been applied. And lastly, for end-to-end, and this is usually the most expensive form of testing because it requires the entire infrastructure to be up and running before it can be conducted. And end-to-end is usually done in the context of from the perspective of the end user when they're interacting with their applications. And with Terraform, this test can be performed through each of these different capabilities. So we can use Terraform check for our end-to-end tests. We can use Terraform test for our integration and our unit testing. And we can have validation and pre and post condition checks for our contract tests. But our focus for today will be on the Terraform test capability within this pyramid. So this is a typical producer-consumer workflow for a Terraform module. And at the top, we have the platform team, who are the producers, and they are the one that's responsible for crafting and deploying modules to be used by the rest of the organization. And at the bottom, we have the application team. So these are the ones that consume the published modules to deploy resources into the environment. So the application team will essentially write a template that references the module and then do a Terraform plan and apply to create the resources. And as cloud adoption increases within the organization and the number of consumer increases, we needed a mechanism to ensure that the modules that have been published by the platform team is well tested and would not cause any unexpected breaking changes for the downstream consumers. And this is where Terraform test comes into play, and it provides a systematic and automated approach to testing changes to Terraform files. Here, before any changes can be published, we can automate a set of predefined tests to run the module against. And only when the test passes do we allow the module to be published. And with this, any unexpected changes can be caught before it is rolled out to the rest of the organization. So this is how the full end-to-end flow will look like. We have the platform team first writing the modules and then having some form of Terraform tests, ideally through some form of automated capabilities, and before publishing the module. And once the module is published, then again, the application team will consume the module to deploy the resources. And with that context in place, let's dig into the Terraform test framework. And this is available in Terraform 1.6 and higher. So the idea here is we have all the tests that we are trying to run is written in the HCL format, the HashiCorp configuration language, and it must end with a .tf test.hcl extension. To execute a test, we run the command terraform test, and what happens behind the scene is Terraform would then look up all the .tf test.hcl files within your directory and consolidate all the different tests and then running the test against what has been defined. So one thing to note, the tests are always executed with temporary in-memories, and so it doesn't affect your existing live resources. So say you have an existing deployment that deployed certain cloud resources, and now I want to do a test on my Terraform file. The test itself will not affect the live resources. There will be no changes to it. And if Terraform test needs to create any resources, it also does the automatic cleanup of these resources, helping to streamline your test experience. So engineers and developers don't have to worry about having to clean up after they've done their testing. So if we look at the anatomy of a test, these are some of the key blocks to look out for when we are looking into a Terraform test file. So whenever we publish a module, there are certain attributes or variables that we expose to be taken in as input when we want to deploy the module itself. So the variables block is the mechanism for us to input the variables for the modules that we want to test against. So in this case, I have the variable block, and I'm passing in the value of test to the bucket prefix variable. Then we have the provider block, similar to how we have providers. We provide provider blocks to our Terraform files, so Terraform knows how to interact with the external integration. The provider block allows the Terraform test to also integrate with external integrations if it's needed. Then we have the actual run block, and this is the actual unit test itself that we are running against. In this case, we have defined a unit test for valid string concat. 3A is interesting. So this is the command itself. There are two possible values that's allowed here. One is apply, which is the default, and plan. So as the name suggests, if the command is an apply, what happens behind the scene when you do a Terraform test is that the test would create the resources that's needed. And once the test has been conducted, Terraform then destroys the resources that have been created. Whereas if the command is a plan, Terraform then does a speculative plan and then checking the plan against the conditions that have been defined for the test itself. Then we have the assert block, and this is the actual condition checks that we are applying against the resources that we want to test. So in this case, we are checking for the condition that if I'm passing in the prefix of test to my module, I expect the resource and the name of the bucket to be of test bucket when it's returned at the end. There's also an associated error message for when the condition fails, and in this case, it would say that the S3 bucket name did not match what is expected. So other blocks include our pre-run variables, provider, and module blocks, some of which we will go through later on in the slides. And within a Terraform test file, at the top, we have a variables that is at the root level, and this can be seen as sort of a global variable that can be applied to all the run blocks that has been defined within your test file. So in this case, we have a global variable of bucket prefix equals to test. But we can override this variable within our run block if you want to test for other cases. So in this case, within the run overrides root level value, we define another variable block with a value of other for the bucket prefix. So in this case, when we are checking for our condition, we are expecting that the bucket name to be of other bucket instead of test bucket, since the new variable value is being used for this particular test itself. And when we are doing tests, there may be certain situations where a successful test is a result of having some form of failure against the conditions that we want to check against. So in this example, we have a variable region that only allows two given input, AP Southeast 1 and AP Southeast 2. So for this test to be successful, where we are looking for invalid valid region, if we pass the region of US is 1 into the variable, we expect this variable to fail for the test to be successful. And how we define that is using the expect failures block. Here we can give the expect failures the value of var.region to expect the region variable to fail when we pass in the value of US is 1. And if we put everything together, this is roughly how it would look like. At the top left, we have our s3.tf. So this is our usual Terraform file where we have our variables. So here we have a variable for bucket name and a variable for region, and the actual resource that we are trying to create. So here we are just trying to create an S3 bucket resource. We are taking in the bucket name and adding a dash bucket suffix. On the right, we have the actual test that we have created for this particular module. Here we are running two sets of tests. First is the valid bucket name, and second is the invalid region. So for the valid bucket name, if we pass in the variable of test for the bucket name, we want to check that the bucket name, when it returns, ends with a dash bucket to make sure that the suffix has already been added. And for the invalid region, we are checking to see that if we pass US is 1 into the region, that the region should fail. And for us to conduct this test, we just simply do a Terraform test. And Terraform would then look up for all the test.html files, consolidate all the different run blocks, and then conducting the test. So for more advanced use cases for tests, there may be certain prerequisites or requirements where we want to do some form of certain baseline before we deploy our resources. So in this example, before we deploy our resource, we needed to set up a network. So Terraform test also supports the calling or the execution of existing modules to set up the environment that's needed for your test itself. So in this example, we are calling the networking module to create our VPCs and subnets. And before we run the test itself, we then get the VPC information and then passing it into the test before we do our actual test itself. And so we can sort of chain the dependencies between different modules before the test is being conducted. And with Terraform 1.7, we introduced the concept of test mocking. So mocking allows us to provide sort of like a replacement or a local copy of the different resources that we are trying to interact with. In this example, we are trying to mock the AWS provider. So conventionally, if you want to create, when we are doing our Terraform test, and we provide the AWS provider, the test will reach out to the actual AWS provider and creating resources into your AWS account. If we mock the provider itself, essentially what we do is it creates a random data for all the different calculated attributes within the provider. So things like your S3 bucket, your EC2 modules, this has been replaced by a local copy of what Terraform would expect expect the real provider to provide. So this is especially useful when we want to run tests in an environment where, say, you don't have access credentials to your cloud account. So you can mock the provider, allowing Terraform to run the test without ever having to interact with AWS. And this is also useful if you want to run the test, if you want to improve the speed and performance of your test itself. And because we are mocking the provider, there's no actual API calls being sent to AWS. We are not waiting for resources to be created. Everything can be done locally within your testing environment. So besides mocking the provider, we can also mock resources and our data sources. So in this example, we are mocking the AWS S3 bucket resource. And we are saying that whenever we are trying to create the AWS S3 bucket, we will return the ARN in this particular format. Same goes for when we are trying to data source for AWS S3 bucket, we will return the value using this particular format. And another powerful feature, this is a feature that's only available on the HCP Terraform, is the ability to generate our module tests. So using a large language model trained on HCL and the Terraform test framework, when a new module is published within Terraform Cloud will can look at the file, understand how it's being created, and provide suggestions and sample codes as to what kind of tests you could run against your module. And so this essentially helps to lower the time needed to craft out the different tests and using whatever has been recommended as a baseline for your and then expanding on this set of test suite for your module. And also, if you are using HCP Terraform, there is a built-in mechanism to help automatically run the test whenever there's changes being pushed to your module itself. So that's for the content. I'm going to run through the actual demo itself. So here in my IDE, I have my Terraform AWS S3 module. And so the file itself is very similar to the ones that I've shown in the slides earlier. So here I'm creating my S3 bucket. I'm taking in the a variable of bucket name and adding the bucket suffix. And I also have some form of encryption configuration for the bucket itself. So I've added all my test files in the test directory under s3.tf test.hcl. And here I am running two unit tests. First for a valid bucket name and second for an invalid region. So I'm passing in my variables of leaks demo, and here I'm overriding it to be leaks demo 1, and having a condition to check that when I create a bucket, that it adds the bucket name leaks demo 1 has the appropriate suffix of dash bucket that has been defined. And second, for the invalid region, I'm passing it a region of US is 1, and I'm expecting the region to fail. If we look at variables.tf here, the region, these are the list of acceptable values, US is 1 not being any of them. So for me to run the test within my Terraform AWS S3 directory, I just do a Terraform test. Terraform would then look up all the different test files and then running the test against it. So I'm also going to push and change to my file so that we can see what happens when we use the Terraform console. So in this example, I'm adding a new variable, and I'm just going to push the change up to my repository. So this is my Terraform console itself. Sorry, my session has expired. I'll need to log in again. And under my registry, I have my S3 module. So my repository has already been integrated with my VCS, GitHub in this case, and the module registry has been used to, has been configured to point to the repo. So within this repo, you can see that there is a view all tests button. If we click on it, these are all the different tests that has been executed against this module. So when we added a new variable earlier, we can see that Terraform has already automatically done a Terraform test to test for the new changes. If we click on the test itself, these are the unit tests that has been executed. And once we have tested and we are happy with the module, we can then publish a new version. And when we publish a new version, we get to see what has been the test result for this particular version that we want to publish. In this case, I'm going to publish the latest commit, and I have a 0.012. So, and So once you have published a new version, then 0.012 will soon become available for the rest of the organization. The other capability within HCP Terraform is the ability to do test generation. Just take note that this is still a beta feature, but essentially where you could use HCP Terraform to generate a test file. So here, Terraform looks and understands the file that has been given and then determine some form of unit test that can, the appropriate unit test that can be run against. So earlier when I was creating when I was defining my module, I didn't have any tests for encryption configuration. So HCP Terraform has given some recommendation as to, okay, this is the kind of, this is a unit test that you could add for your module itself. And for the new variable that has been added, these are suggesting some checks that I could run. So from a developer and an engineer point of view, I could just copy this set of tests that has been generated and then pasting it into my module to have some form of, to have some baseline checks for my module before I publish it. So with that, I've come to the end of the demo. But if you would like to learn more about Terraform tests, we have a nice blog about the Terraform test framework. So feel free to, scan the QR code or visit the URL to learn more. And with that, that's all for this snapshot.